Alright, let's discuss about even and odd signals. Even signal is generally known as symmetric signal, whereas odd signal is generally known as anti-symmetric signal. For an even signal, x of minus t equal to xt, that means if you for a signal, if you find the value at t equal to 5 second is something like, for t equal to 5 second value is say 2. For t equal to minus 5 second the value is again 2. So that is the even signal. So this is the even signal because from 0 to 1 the value is decreasing from 1 to 0. So at zero point 0.5 t equal to 0.5 the value is 0.5. You can assume that for here also for t equal to minus 0.5 the value is 0.5. So that means x of minus t equal to xt. It satisfies the condition for all values of t. For all values of t, suppose for 2 t equal to 2 the value is 0, for t equal to minus 2 the value is also 0. So it satisfies the equation. So that means it is a even signal. So another example of a even signal is a cosine wave. For a xt equal to a cos t, that is also a even signal. Here you can see, so the signal is started from 0 and value is a. For a cos t value is a at 0, then it's changing, and for 1.5 the value is minus a, and here for minus 1.5 the value is minus a, and for 2.5 the value is a, and for 2.5 again the value is a. So that satisfy the previous equation or condition, x of minus t equal to xt for all t. So it's again an even signal. Now, if we see this example here, for 1 t equal to 1, here is the time, positive time, and here is negative time. So for t equal to 1, the value is 1. For t equal to 2, the value is 2. Here, for t equal to minus 1, value is not 1, but value is minus 1. For t equal to 2, the value was 2, but here for t equal to minus 2 the value is minus 2. So that means x of minus t equal to xt. So x of minus t equal to xt for all t. If any signal satisfies this condition, then we can say the signal is a odd signal or anti-symmetric signal. So a sinusoidal signal a sin t is an odd signal because you start from 0, at 0 the value is 0, but for 1, suppose the time is 1 over here, so value is a. For minus 1 the value is minus a. That means it's just reverse the value, same value but the sign is different. So we can say x of minus t equal to minus xt for all t. This condition satisfied here. So that is a odd signal. So we can develop some equation of even and odd signal. So any signal, suppose any continuous type signal, you can say it's xt. Is less any signal. So xt may be combination of two parts. So every signal is a combination of two parts, one even part and another is odd part. So suppose the signal xt equal to a cos t, then you will say the cos t means it's a even signal. So where is the odd part? Odd part is 0. But suppose a signal is a combination of xt equal to cos t plus sin t. So here the even part is cos t and odd part is sin t. So any signal can be expressed as even and odd part, that is xet and xot. So if you put x of minus t in xt, if you put x of minus t, then you can write x of minus t equal to xe minus t even part and xo odd part o minus t. So we know from those previous two equations that for an even part x of minus t equal to xt, so we write just xet, and for odd part x of minus t equal to minus xt, so we write minus xot. So if we add those two equations 1 and 2, then we can find out that if you add those equations, then xot will cancel out and 2x et equal to xt plus x of minus t. So from there you can find out x et equal to half xt plus x of minus t. In similar way, if you subtract those two equation 1 minus 2, equation 1 minus equation 2, then you will get xot equal to half of xt minus x of minus t. So those are the two equations we find out to find out the even and odd part of a particular signal. So that was for the continuous signal. So if we go for discrete signal, then we can say that any discrete signal can be expressed as xn, that is a combination of two part, even part and odd part, xen and xon. So if you put x of minus n, then x of minus n equal to xe minus n, xo minus n, even and odd part. So if you add those two equations, and from previous equations we can say that for even part x of minus n equal to xen, and for odd if you x of minus n equal to minus xon. So that is the thing, and if you add those two equations 1 and 2, then you will get x of en even part is half of xn plus x of minus n, and if you subtract those two equations, then you will get xon equal to half of xn minus x of minus n. And now we will discuss some problem regarding even and odd signals. So in problem 1, a signal is given that xt is a continuous type of signal and it is a combination of three signals. So the signal is cos t plus sin t plus cos t sin t. So you have to find out the even part and odd part of that signal. So we know the formula or the equations that x e t, even part of a particular signal, is a half into x of t plus x of minus t. So x of t is cos t plus sin t plus cos t sin t. So we put for xt from here to here, and for x of minus t, that means you have to put minus t in place of t. That means cos of minus t is cos t because it's a even signal, and sin of minus t is minus sin t because it's a odd signal, and if you put here cos of minus t, that is cos t, but sin of minus t is minus sin t, so it's become minus cos t sin t. So I just write those things, and if you just calculate all those things, then you will get x of et, even part is cos t. So even part of the problem of xt is cos t. So what part will be sin t plus cos t sin t? Let's find out it's come or not. So x ot is half of xt minus x of minus t. We know xt equal to cos t plus sin t plus cos t sin t, and minus x of minus t, we find out x of minus t. So minus x of minus t means minus cos t plus sin t and plus cos t sin t. So it's become sin t plus cos t sin t. So we find out the even and odd part of that signal. So we will find out for a discrete signal. Suppose the problem is given for a discrete signal xn equal to minus 2 1 2 minus 1 3, and arrow is under 2, that means that is x0. So x0 at n equal to 0, the value is 2, so that is your 0, n equal to 0, so n equal to 1, n equal to 2, and it's n equal to minus 1, n equal to minus 2. I just put all those values. For 1 it's minus 1, for 2 it's 3, and for minus 1 it's 1, and for minus 2 it's minus 2. So that is your xn. So I just put the order of the n: minus 1, minus 2, minus 1, 0, 1 and 2. So we know the equations for discrete even part of a particular signal. xen is half xn plus x of minus n. So if you put n equal to 0 over here, so you have to find out the discrete part discrete even part of a signal xn, then you have to put n equal to 0 in that equation. So if you put n equal to 0, then you will get xe0 plus half of x0 plus x of minus 0. X of minus 0 is x0, again x0. So here I can put the value from here, because x0 is 2 and x of minus 0 is again x0, that is also 2. So half of 2 plus 2 is 2. So we find out the even part of a particular xe0 sample, that is 2, and then we will find xe1 next sample. So if you put n equal to 1 in that above equation, then you will get half of xn plus x of minus n, and here x1 is minus 1 and x2 and x of minus 1 is 1. So this become minus 1 plus 1 is 0, and if you put 2, then you will get x e2, that is half minus 3 plus 2 from that above figure is 0.5. So you find out the thing that at 0 value is 2, because x e0 equal to 2, x e1 equal to 0, x2 x e2 equal to 0.5, and we know for a even signal the left side and right side will be same, the value will be same. If the value of x1 is the same of value of x of minus 1, so you just find out one side of that even signal. So I find out the right side of that even signal. So for 1 is 0, that means for minus 1 is again 0. For 2 is 0.5, that means for minus 2 is 0.5. You don't have to calculate all those things, just you find out one side, then you will get another side. And for odd signal, if you find this side and again you will find this side, because but the value will be opposite sign, that means 0 is 0, but here is 0.5, it will be minus 0.5 for odd signal. So the final signal odd part xen is 0.5, 0.5, 2, 1, 0.5, and here is the arrow under 2 because it's xe0. And in similar way, you can find out the odd part of that xon of that of that given signal. So odd part is half of xn minus x of minus n, and so x0, if you put n equal to 0, then you will get xo0, that is half of x0 minus x of minus 0, that is minus 2, that is 2 minus 2, 2 minus 2, that is 0, because here is the signal at 0 the value is 2, so x0 is 2, so x of 0 minus x of 0, that is 2 minus 2, again 0. And for x1, if you put xo1, that means if you put n equal to 1, then you will get a half of x1 minus x of minus 1, that is minus 1, that is minus 1, minus of 1, that is minus 2, into half, that is minus 1. Again, if you find out the xo2, that is half of x2 minus of minus of x of minus 2, there that will be 2.5. So finally here you can see we find out at x0, at xo0 it is 0, and xo1 that is 1, and xo2 that is 2.5. So that is your even part, and that is your right side. So the left side will be just opposite. Here for 1 is minus 1, it will be 1, and for 2 is 2.5, here it will be minus 2.5, because for the odd part it's just reverse the sign. Thank you for watching this video. If you find it's helpful, then you can subscribe my channel and share this video to others. Thank you very much.